Welcome back to another episode of the Additive Snack podcast. I'm your host, Fabian Ahlefeld, and today we are diving into the fascinating world of high performance and custom bicycles, combined with the very interesting impact of additive manufacturing. I haven't touched bikes in a while. When I grew up in Germany, the bicycle was always our main form of transportation. Whenever I can think of my childhood, there's usually a bike involved. We used to ride these cheap bikes down old rail hills and through the woods, and they brought us to school every day. But since I moved to Austin, Texas, the exposure hasn't been that great. And therefore, I'm super excited to get back into this topic again, especially because we're combining it with additive manufacturing. And therefore, I invited two really awesome people out of the industry. First, we have Chris Henry, the owner and founder of 44 Bikes, a company well known for its high quality custom bicycles. And Chris has a very unique background that we'll also talk about that really brings us into the additive space. Alongside Chris, we also have Spencer Thompson. Spencer's main role at EOS is actually the lead engineer for environmental technologies. But besides the fact that Spencer has worked on various industries from automotive to space to medical, he also is a passionate bike enthusiast and has really gone deep into the topic. Right? He looked at all angles of additive manufacturing, how it can impact the industry. And therefore, Spencer is the guy to call when it comes to bikes in the AM space. So I did. And here we are. So without further ado, Chris and Spencer, welcome to Additive Snack.
Awesome. Thanks for having me. Thanks for having us.
All right, cool. So let's dive right in because not everybody is familiar with the company that you built, Chris. Could you tell us a little bit more about 44 Bikes?
Sure. I own a small bicycle company in southern New Hampshire, and my trajectory into bicycles probably is similar to yours as well as to a lot of other kids. I grew up in just north of Philadelphia in a small rural, it was a old rural farming community, but just outside of town, there was a lot of open space. But in town, there are the three boroughs, Greenville, where I grew up, Pennsford, Red Hill, traditional Roman block, tree-lined streets, pretty idyllic. In my first bike, a hand-me-down, I think it was a green hand-me-down Schwinn. I get excited. Mom takes me out front, shows me the ropes, and off I go. And it was one of those things where I had certain limits. So just starting out, it was to the telephone pole, which is not even half a block. Then it was to the end of the block. And then the big moment is being allowed to go around the block. So you go around the corner and mom and dad, everything you hold dear is gone. And that definitely set the hook, right? Because bicycles are independence and there's a degree of freedom there. It's a huge confidence builder because you're on your own. So that led many adventures, and lo and behold, that's what I settled on as my major. So I was a goldsmith and a silversmith for a number of years. But then while I was at school, I was doing some research on a project and I bumped into a German jeweler's name by the name of Peter Skubik. And his work was, the stuff I was looking at and researching was mostly stainless steel brooches held together in tension with watch pins, which stainless steel is pretty difficult to work with, especially as a jeweler. And this stuff just fascinated me. But beside his name was industrial designer. And in this catalog of his work, there was also sketches of products. I think there was like space gloves, like aerospace gloves. There was goggles, glasses, helmets, like all this crazy stuff that, what is this industrial design? So that led me on this journey across campus because Penn State, 40,000 undergrads, it's a huge campus and there is a ton of facilities right at your fingertips. So I went to anyone and everyone that would talk to me. And essentially that led me back to the jewelry department, ironically, because everyone kept saying, look up the Rhode Island School of Design. And one thing led to the other, and I decided to graduate and then visit the school possibly for graduate work. And it actually turned into a second undergrad degree in industrial design. So from there, I went to Reebok and Converse as a shoe designer. But my dream always was, ever since I was a little kid, to create my own bike company. And when I went out on my own as a consultant in design, like in product design and graphic design, I was working in the evenings or in downtime on 44 bikes. I was doing the branding. I was doing all the design work for it. And pretty much once all that was figured out, I think because of RISD's, like kind of their hands-on experience that they provide with facilities, given the fact that I was born in 1975, like um, my education and schooling was like my generation, Generation X kind of bridged that gap of technology, but old school, like hands-on drafting, machining, turning. Like in my middle school, they had a fork. Everyone had to take metal shop. Everyone had to take wood shop. We were casting metal, welding, crazy stuff in this middle and little pits.
Hmm.
But that I had my hands on lathes, on Bridgeports, on welder at a very early age. And it just gave me this taste of, oh, wow, I really love making things and creating things and combining that, combining my love of bicycles with my passion for design and things that just formulated 44 bikes. That's what everything funneled into that.
Yeah, that's a very interesting story, and I think your background can also be seen in the creations that you now make. And you said you started the company in
Yeah.
2012.
In
Is that correct? 2012. Yeah.
2007 is really when I graduated from RISD in 2002. And then 2007 is actually all along there. I was fiddling in paper and on the computer. But then in 2007 is when I actually started like welding again and then actually starting to have access to a shop and things like that. In 2006, we had moved up to New Hampshire. So that move coincided with our home having a space, which I'm sitting in now. So I built that out in 2011. And really the design consultancy that after I finished work at Converse and started my own design consultants, which really focused on branding is what it focused on. A big part of that was there was some downtime. And so I was focused on this and pretty much everything that I did focused on funneling whatever time and funds that I had towards this project. So
Yeah. So when you started the company, you probably mainly relied on conventional manufacturing technologies that either you first saw in middle school or picked up along the way, and probably also relied on a lot of external suppliers. And at some point along the way, additive manufacturing shows
yes.
up. What role did or does additive manufacturing now play in your journey to deliver these custom high performance bikes to
So I
customers?
guess really additive came into play. I had been working as a frame builder for over a decade and I was solely focused on hardtail. So gravel bikes and mountain bikes and just understanding
Mhm.
fit and geometry and handling and how all those play together and developing that understanding experience and then the methodology from the design standpoint of view, that was a lot just to figure out. And after about 10 years of doing that, I finally felt as though now I'm ready to actually start adding moving parts, i.e. like a full suspension bike. And I peaked in terms of what I could do or understand. It was just all the things that I was learning were smaller incremental steps. And I wanted a new challenge. So in 2019, I started out on a full suspension project. And I was working with a local machinist to have something CNC machine. Because part of that project was I wanted to have a fully realized drawing in Fusion 360, a CAD model. Because up until that point, I was just drafting into. So that was one design goal. Second one was to actually have parts that I designed, then manufactured. And up until that point, I was using mostly off the shelf parts or parts that I was making in house in terms of how I'm forming or bending to. So really the big challenge in the kind of work that I, in the custom world is essentially trying to make round tubes not look like round tubes. Because there's only a limited number of suppliers and because CNC machining has a barrier of entry, not in terms of experience, but also expense. And obviously, it'd be really great if I had a CNC on here, but that's not feasible at this point. I'm on a 5-year plan to get one, but the issue is, again, making round tubes not look like round tubes and developing something that is uniquely your own. And I ran into an issue with the CNC machinist going silent and just dropping the project even before that basically began. That forced me into what other manufacturing processes can I look at that are affordable, fast turnaround, and I can work on prototyping and rapidly produce iterations. And that's where 3D printing really came. And specifically, like where I started was in the bottom bracket area of the bike, specifically the yoke on a hardtail at first. This is one of my chainstays. Starts as a round tube, thins out. There's forming here for tire clearance. There's forming through the center for lateral stiffness. But right in this portion, there's always a discrepancy in terms of you got to pack a lot of stuff right in this region. So you have chain ring, tire clearance, all that stuff. And 3D printing really started helping transform that. So now I can have tire clearance, chain ring clearance, but make this part has a spline down the center for lateral stiffness and durability. Works on a tube and socket. So it's like the technology is 21st century, but tube and socket is essentially where bicycles started, lugs and tubes. So we're right back where we started, only in this really crazy new technology. And so I can make a tube not look like a round tube, but also I can solve problems that are inherent material restrictions and different restrictions that I have. But then I can also make and realize a bike that really is unique just to my brand of bicycles. So 44 bikes, it's like these parts are then exclusive, just the 44 bikes. And moving into the full suspension project, like to manufacture this out of one piece or two pieces or have it CNC'd or cast, like those are all that's a hard ask. And 3D printing, one of the big things about 3D printing was suddenly I don't have access just to the outside. I have access to the inside of the part too, as well. So I can fully realize geometry, all the different, I can realize wall thicknesses. I can vary those things. I can add internal support structures. I'm no longer bound by like, how's it being held in this operation? How is it held being not? As an industrial designer, you can see some of the tooling behind me. I'm constantly building a bike is like, how do I hold this to make this one operate? That's manufacturing for me.
Yeah.
This combines a lot of those things.
Yeah, it's very interesting. If we talk on a high level about additive applications, we typically look at, and oftentimes either or, a supply chain application for additive, or we look at a performance application of additive. And you've really leveraged both, right? You realize that reducing lead times and access to low volume parts is very
That's
feasible when you leverage
from my
additive. But then
side, it's
you,
very restrictive because essentially when you start out your prototyping and you're going through a lot of iterations and CNC, although it has its place, it's not going anywhere in my in my process. 3D printing now starts to say, okay, I can start combining things like my main pivot with this full suspension bike. That includes a bent tube, a dropper post socket, and the main pivot, which has bearing bores plus bearing bore clips for stops. So instead of 3 parts with multiple operation, I can have this part printed to my design, like with all the features already done, tolerance, and then there's only a few post-print operations that I have to do. It's a huge time saver, but also it could be a potential funding opportunity too, because now there's multiple operations that I'm eliminating on the expense side that suddenly now it's in one part. And that for me, full suspension project, that's where I am now. Like, where does water jet and laser cut fit in? Where does CNC fit in? Where does SLM fit in? And how are all those then leveraged to make it the most cost effective, but the most efficient to build? Ironically, it's actually funny. People ask me like, how long does it take me to make one of those full suspension bikes? And I have to laugh because of all the design time and because of 3D printing, it's actually the easiest bike to make. It's the fastest bike. Even though
how long does it take you?
Yeah. So
how long does it take you to get one bike from start to finish?
Typically start to finish from paint would be 40 hours. But if we're just talking like just my work, I can crank out a bike in about 6 to 8 hours custom from start to finish.
Wow.
I don't stop.
Wow. Okay. That's
and so
that's really
because
cool.
a full suspension bike is 2 halves, you have a rear triangle, a front triangle. You don't have to deal with a lot of like stack tolerances or alignment issues right from the start. because you're aligning two parts and then you're using pivot points and precision bores and things like other alignment things to maintain alignment throughout the whole process. But it is the full suspension, ironically, is the most, it's the, because of all that design time and because of all that forethought that I'm putting into the 3D parts, that then speeds me up when I'm actually here in the shop making shows. Then.
Okay, so we have lead time increase. We have potential cost reduction as an impact for your business. You have a bike
Yep.
behind you, and I obviously, like I outed myself, I used to know my bikes. I'm not super deep anymore. We now talked about a few performance impacts, right? Like the stiffness in a certain direction. What does this mean for the user, the rider? Is there an impact on performance, on feel, on accuracy? What is the impact
So
there?
what I found is because I'm able to have more control over the parts and more of the operation, like more of the design and thought that goes into them ahead of time. I'm not just thinking about like how this bike handles out on the trail. I'm also thinking about what happens when this thing has to actually be maintained. So you got a squeaky pivot. Okay, so now bearings have to be placed. Okay, you have to like all that stuff I'm thinking about. And so one of the design goals also was to utilize as many stock hardware off the shelf, number one, but also ease maintenance. And all those things then are considered from the front end of the design phase all the way through into like final product, which is sitting behind me. And so what I've found is the bike is easier to work on. The bike,
Mhm.
maintenance wise, I am pretty meticulous about my own bikes. I'm always tinkering with them. I'm always breaking them down, things like that, because I have the time. And I know not everyone's like that. So this is the fourth prototype that I made. I purposely just, aside from bleeding brakes and putting air in tires and patching tires, like that kind of stuff, I was like, I'm just going to neglect this thing. It stayed quiet. Things are where they should be. So things are running smoothly. I'm not, there's no, that noise is getting at me again. Like, just because of varying conditions with Northeast,
Yeah.
sometimes we'll have very arid summers, sometimes we'll have very wet summers. This summer was very wet. So it's like it changed your maintenance cycles and things like that. I am the test dummy essentially right now. So those are the things that are important to me. And maintenance is high up on the list. Like when things go wrong, this has to be easy to work on. So 3D printing definitely has helped that because I have more control over all those factors.
Yeah. And you consolidated parts, you reduced failure points, therefore, very interesting. Spencer, you, as I mentioned earlier, you've been in additive for a very long time, really, for the fact that the industry is quite young. And as I mentioned also, you looked at various components in various industries. And you're a bike guy, so you dove deep into the industry and really tried to analyze how is additive manufacturing being adopted in that industry? How is it adding value to that industry? And you've even launched a bunch of articles that kind of line out your findings. Can you share with us a little bit what the current state of adoption is and where you see some of the impacts of additive?
Yeah. Yeah. First of all, that's the bikes for me because I'm a bike neglector. I do not take great care, unfortunately. Yeah. I got into bikes and I was riding around with some friends that had frame builder friends, and they found out that I was 3D printing, and they were like, "Oh, I've heard of this. What can you make? What type of material?" And it just led to a chain of different connections, all the way to finding Chris one day and then just saying, "Hey, if bikes, 3D printing is really having a moment right now. Everybody's looking into it for all the reasons Chris said." So first and foremost, rapid prototyping, ability to create designs fast, guide them, weld them up and go ride them, and tweak it and get a nut in a week. That's opening up a whole level of design that I don't think was there, especially to smaller shops. It seems like having access, like you said, complex, like people can't, it's opening up there. If we go to like medium and large, go to somebody like Chris, custom bikes, and using 3D printing, 7 different sizes or specifically designed for your size. And that's a lot easier to do. There, you're just tweaking some dimensions on a CAD model. And that, if you tried to make it, and Chris, please correct me here, but if you tried to make it, you'd have to weld. You have two mounting posts that you have to miter a tube to then weld the posts. And so you're doing tons of little welds inside of a very small part. It's difficult to do, especially with titanium, where heat's really important to control. And so now we can make these really complex parts without having to do all those big, complex or challenging welds, and then just have that tube and socket joint. And so one easy weld without all the miters and complexity. So a whole lot of stuff is going to continue to grow.
And it seems to me that we're also just scratching the surface, right? You started looking into bikes how many years ago, Spencer? When it comes to additive.
For my job,
course,
yeah, about a year, I would say. And then, 6 months have really turned it on as this is a real thing and it's going to grow. Yeah.
Yeah.
Okay. And Chris, when did you get into additive?
2019. So that's
19.
Really was
okay.
When I seriously took a look at it, it was like, okay, this totally changes everything. Because now I'm not restricted by machine operations. It's all built out per weight of powder. And along the way, I've learned a lot about 3D printing and the process, but it's taught me a lot about my own bikes. And it's just made my bikes better because I've spent so much time in that headspace and in that design space working with it. It's a really powerful new tool in my tool chest. Like I said earlier, CNC is not going anywhere. Water jet cutting isn't going anywhere. Laser cutting isn't going anywhere. This is just like another really amazing tool in the shop to make better bikes and to really solve problems that to combine operations, but then also solve problems that have consistently nagged me and nagged other builders, like that flat mill discussion. Those two studs that you have to weld, it's in a small location. There's a lot of shrinkage that you're dealing with the weld. So right off the bat, you're dealing with alignment issues, and the brake is now tied to the frame's alignment. And it's just basically that design is from Shimano. It's just one headache after another in terms of it was made for carbon, really, or designed for carbon. And 3D printing now completely solves all those manufacturing headaches and all welding headaches that even with all the years I have over 20, 30 years of welding experience, these are really difficult welds to make because you have to really be on your game in terms of heat control and purge, all the tools that you have to make for the stuff. So it's like all that's gone. Just that as a small, like little,
it really,
really solving headaches and solving problems.
Yeah, it makes challenging designs or new designs accessible to smaller bike builders like yourselves that don't have access to various manufacturing equipment and processing chains. And I could imagine it also reduces the independence or increases the independence a little bit more by reducing dependency on suppliers, on also certain more complex supply chains that, as we all see in the news right now, are breaking down again because there's supply chain interruptions in the Red Sea. Spencer, you wrote an article even focusing just on the supply chain aspects of additive manufacturing. Do you see a trend here? Do you see also a long-term transition possibly just because supply chain can be challenging?
Yeah, I think we're seeing this very clear to anyone that pays attention to manufacturing, that we're seeing in all different industries. There's definitely a supply chain buzz about how do we not have what happened in 2020 and 2021 again, and really impacted by a boom in 2020. Everybody wanted a bike to go outside and ride around. And then now I think there was an oversupply. And there's some interesting things happening. And I'd love to hear your input on that, Chris. But I think just having awareness of, producing locally has not only just an advantage from the complex supply chain from ordering stuff from overseas, but also has an advantage for cost, for the environment, to get things quicker, and also help people, other people with jobs in their community. So the bike industry seems to be really interested in that. And I think additive will provide a solution for people to make that happen.
Do you see that from your perspective as well?
Yeah. If one thing that the pandemic really taught me is people have money now and they want to spend it now. And that forced me to look at my business model in terms of custom and the restrictions that produces all by itself, because those are long lead times, and moving into a small batch production environment where I'm making 5 over 10 of. Okay. And there is definitely a market within the cycling community that they aren't necessarily custom customers, but they're definitely not production customers, like just off the shelf. They want to know who made it, who made the product. They want to know where it was made. They love the whole backstory behind the product, and they're willing to spend a little extra that small batch production type product available to them. So 3D printing, that has opened up those avenues and made certain restrictions in terms of from custom to small batch very much possible because of all these problems and restrictions that I was dealing with before. Now those have kind of fallen away. And now it's just partnering with the right manufacturers that understand and get the bike industry and are on board with small batch production. That in the 3D printing environment can be a challenge. And long term, it'll be really interesting how everything shakes out.
Have you ever had issues with a supplier if you said, I want 5 of these parts and they're like, get out of here?
Well,
Like,
especially in that. So my experience with 3D printing and those manufacturers, they're almost exclusively aerospace and medical. So they're used to big pocketbooks, limitless spending, and they want large production. And I totally understand. I totally respect. There is another segment in the market, the custom builder, or the small builder like myself and others, where we might be doing 5 of, 10 of, 100 of, 200 of. Hitchgear Manufacturing is right down the street. They're an injection molder. The things that they do in one day is mind-boggling. When I took a tour, it's like, but for me, it's to find manufacturing partners that understand and get it. For example, one of my manufacturing partners in 3D printing space, they get it. They do a lot of stuff for other builders and other mid-tier bicycle builders, and they print all of my titanium parts. So all my titanium parts are printed in the United States. All of my stainless parts are printed by Iran. And so far, so good. But that ability in prototyping and also the ability to make changes on the fly, that is one thing that I definitely learned at a large global company like a Reebok or a Converse, where they send teams of designers overseas to the manufacturing plant. So design is separated from manufacturing. And what I've traditionally seen in experiences, that can be a huge hindrance because the companies that get it and have all that combined stack. Whereas it's production change overseas, we have to have a meet. We have to have that. Like we have to send a team over there. So it's like months and months of back and forth before you actually see changes. I can make changes. Like if I wanted to change something today, I can literally walk up to my studio, make the changes, send them to my printer. They're here, within that whatever lead time that they're looking at. It's like the expense is less. You're not having to send huge teams overseas. That expense is gone. You have production times are now shrunk. Development times are increased fast, are now rapid. And you have the ability to make changes on the fly at least at my level, heartbeat. And that just makes the product better. And that makes my customer happy. Because isn't that the goal, to make your customer happy? To provide them with the best bicycle that I can provide.
Yeah, Spencer for sure would sign that part. And I think it's important to double click on one challenge that you just mentioned, which really is being able to order low volume orders of 1 or 2 parts. And open call to anyone out there who potentially owns a contract manufacturer and wants to support this industry. I think we see successful implementations of similar models in other industries, right? We have large dental manufacturers in the United States that get orders from smaller labs that couldn't justify getting their own additive equipment, but also couldn't send a few printed crowns to a standard contract manufacturer. They wouldn't just run a small build like that. But they combine all these orders with one material. They're all numbered and they print them overnight and have a 24-hour turnaround time. This model is possible if there's enough demand out there. So either if you're a contract manufacturer out there or a bike builder, I think joining forces here and funneling the demand to a few organizations, that might be a way to go.
Yeah, that's a big thing that I've been trying to figure out. Especially in the U.S., the additive manufacturing industry is really heavily dominated by aero now. So like what Chris mentioned about being turned away by just being a bike company on 5 parts. It's real. It's a challenge right now, but I think the more that we can show that that people are making amazing world-class bikes with 3D printing and only planning on growing, I think the more that we can fight for getting just machine capacity at the ready and some of these suppliers to take bikes seriously.
Yeah, and that actually is that is one of the hurdles that I've always run into is partnering with manufacturers that are enthusiastic about what I do, because not finding that then slows down development time and essentially restricts my growth. That's what it boils down to. And any lag has either been a lack of enthusiasm or just being plain turned away or a lack of funds or both. So this all plays out further down the road. So yeah.
All right. It's a good call. I have one more question. Is there a project that you have in your mind, you haven't started yet, that seems super exciting or daunting when it comes to additive? Right? Is there a certain component where you think this is the next big thing that I want to work on?
What's interesting is that project is the full suspension project for me right now. And that was the part that was really daunting. And there's still a lot to be learned because there's no book on suspension and there's no book on 3D printing really. So I had to have a lot of trial and error, and it's the build, ride, repeat mantra where I got to build this on Monday, ride it on Friday, and then right back to the drawing board that following Monday. And the faster I can iterate, the more I can learn and the better the iterations can be. But that learning curve, for example, early on, understanding your suppliers and understanding 3D printing world and understanding what you should be expecting from your supplier. So one of the big ones was testing. Is each batch being tested for consistency? Because I had some failures early on from an overseas supplier that A, it was a material issue, but also B, it was like possibly how like the resolution that they're printing at, but also maybe how the powder was being handled, how many times it was being recycled. And then of course, are there inclusions in this? Yada, yada, yada. It's an endless list of things. And for example, if I get a piece of 4130 seamless aircraft tubing in the shop, I know that's actually drawn to a stamp. And I guess the 3D printing world, what would be really cool from my perspective is there is some sort of universal standard that everyone is working towards. And there are protocols that everyone has agreed upon. And manufacturing partners that I work with now, they do 10 bar tests per batch. So if there is a failure or if there's a problem, they will know, or I will know what batch it came from, and then we can make adjustments on it. And apparently some of them are actually making adjustments mid-print or post-print. If that pencil bar test did not pass their own in-house standards, then they reprint all parts. Just because there are so many variables. And that was understanding all that stuff and understanding what the strength of material is from the start, and then what yields post-print, understanding what all those things are was really paramount for me, because then I can go to any manufacturer more informed, and then I can choose the right materials for the right application, where they are on the bike, and certain materials definitely should be in certain parts of the bike. Other materials, it's like, they really do not want any load bearing whatsoever. You know, it's like these are small little raisons, that kind of stuff, like non-load bearing parts. So understanding all those things was really important, and partnering with a manufacturer that gets that and is open to, you know, endless questions and just guiding you through as a newcomer to the industry. That just helps my knowledge. That helps the frame building community's knowledge, because the frame building community is funny where it's like, there's really no open secrets. I would say it's like we're all pretty open about our process for the most part. And there's a lot of information sharing and a lot of sharing in terms of like how each of us are doing things. So we're all learning from each other. And that just makes like the goal, again, like I said, is to make the best bikes we can. So we're working at the community in that information sharing. So it's really important when I go to manufacturers to partner with those that are very open to those discussions, and like hearing the same dumb question 10 times, they're not going to turn me away because it might be new to me, but very routine for them. And I deal with that kind of stuff all the time with my own things.
Yeah, it's a really
Yeah, no,
it's a really refreshing thing about working with the bike industry people is the openness. Like it is unheard to have so much openness in the aerospace world, medical, aerospace, pretty much any other industry, which is exciting because everybody's just trying to learn. But it's a really neat point, and like something that I found from digging through the internet and joining forums is this quality issue with 3D printed parts. A lot of people have gotten bad parts, and I think bike industry has blamed it on 3D printing as a whole and not really pinpointing it as that seems to be a common thread is, oh, this is what 3D printed parts look like. But actually it was that supplier wasn't using the right equipment, taking the right quality metrics and things like that to make sure they're putting out good material.
That's
so
what I
it is important.
do, really.
Yeah.
and it's like you said, also something that doesn't apply to just the bike industry, right? There's, you probably don't want to adhere to FTA standards because that might be a little bit challenging, but there are probably standards that we can steal from other industries that could get you to a point where the quality is a bit more provable and transparent.
Yeah.
And Spencer has worked on similar projects for years in the space industry, so I think he's also a really good resource to the industry itself to help put similar standards potentially together. Spencer, is there a certain project you're working on that you're super pumped about right now?
I'm excited every day that I get to work on bike components. I think a part of my job convincing my managers that the bike industry is a real opportunity, and I wholeheartedly believe it is. I've been working with people like Chris. There's a local bike builder in Austin called Chumba Bikes, and I've been working with them on some new parts. So really, anytime I get to work on a bike part, I am a happy camper.
Well, let's hope that continues I see some of the parts that you have on your desk. They're really cool. Also, not only from a performance perspective, but also from a design and aesthetics perspective, which I think is really cool.
It's cool to see everybody put their own spin on it. Like now you're not just buying a dropout from Paragon but each small company is adding their own flair to what these parts look like and designing and truly making now like the whole bike or a representation of what they want to create, which is super exciting.
Yeah, it is. It's just to reiterate that part from my perspective. For example, when I was working at Reebok or Converse as a shoe designer, I could generate 98% of what I drew and came up with never saw a white guy, which is incredibly disheartening, right? You work a lot on all different types of things, and to have such a large majority not see anything versus on the flip side of owning your own business, my own, all these things that I'm coming up with and designing are essentially seeing the light day. So it's went from 2% to almost 100%. So it's incredibly gratifying, not only to own your own business, but then to realize that vision. And The 3D printing space enables me to realize my vision of what the ideal bicycle is going to be for myself and my customer, and really make it my own, but then theirs.
Man, I couldn't think of a better ending to an episode like that. I do hope that additive, helps you continuously in enhancing your vision, Chris. I think what we've seen so far is already super impressive. We've seen that you've leveraged not only the design aspects of additive, but also the supply chain aspects. And I think that's where I really do hope that we can together lift the whole industry of especially smaller bike builders onto a new level and make these custom bikes also therefore accessible to a broader target and user group. Chris, thank you so much for sharing your journey with us. And the same with you, Spencer. Thank you for being on the pod and sharing expertise and experience. It was great to have you both on the show.
Thanks for having me.
Yeah, thanks.
All right. And to our listeners out there, you heard the call to action. Either reach out to me or directly to Chris and Spencer. We'll add some comments and contacts in the show notes. That was another episode of the Additive Snack podcast. And I hope it got you a bit more of a deeper insight into not only how the bike industry is leveraging additive manufacturing, but I think it also showcases how you see the small seed of additive in an industry slowly grow and hopefully accelerate that growth through accessibility and the topics that we discussed today. So if you like this episode, don't forget to like, subscribe, and to also comment. I will see you next time at the Additive Snack podcast. I'll see you then.